you guys have said how whether it's supervised learning or unsupervised learning, you always have inputs into the model. But what if those inputs are on like completely different kinds of scales? So, one of your inputs has a very narrow range of values and the other one has a very big range of values. Can that have a big negative impact on how your model trains?
Well, yes and no, because that depends on the model that you are using.
Mm.
And the problem is not only about having different scales, because actually you might have all your inputs in the same scale, but you would still need to have to apply feature scaling. So let's give the example of a data set where the features are all between 1 and 10. They're all into the same scale, so there's not this problem of having different scales. Well, yet you would still have to apply feature scaling. So feature scaling is not only about putting all the features in the same scale, it's about putting all the features in the same scale, but that is a short range. And this short range can either be between 0 and 1, and that's normalization. So normalization is, you take your feature, you subtract by the minimum of your feature divided by the difference between the maximum and the minimum of your feature. And then you also have standardization, which will put all your features in the same scale, but not between 0 and 1, but rather between -3 and +3 or -2 and +2. Because the formula of standardization is you take your feature, you subtract the mean of your feature, and then you divide by the standard deviation of your feature. And that will put all the features in the same scales, which will be in a short range. And that will usually improve the performance of your model. But now coming back to your first question, when you asked me, do we have to apply feature scaling? And I told you yes and no. Well, that depends indeed on the model. For some models, you have to apply feature scaling, and I will mention which ones. And for others, you don't. So the best way to understand this is to take, for example, linear regression. With linear regression, you don't have to apply feature scaling. And why is that? That's because the coefficients in linear regression can adapt to put all the products of coefficient times the feature in the same scale. So, if you have one feature in a very large scale and the other, if you have one feature in a very large scale, well, the coefficient associated with it, meaning the one that is multiplied to it, can be very small to, put that product of the coefficient and the feature in the same scale as the other products of coefficient and feature. So that's a good way to understand how feature scaling doesn't have to be applied for linear regression. But there is a rule of thumb in general. There is a way to remember much easily when to apply and when to not apply feature scaling. For example, you always have to apply feature scaling for gradient descent based algorithms, which include logistic regression or all the neural networks based algorithm. So just a quick explanation on what is gradient descent. That's for supervised learning models where you have, a dependent variable to predict. So first you make, your model will make some predictions. Then you will compare your predictions to the ground truth, the labels, the real results, and that incurs a loss. And you will apply a gradient on the loss with respect to the weights. And whenever you use that techniques to reduce the loss with the gradient, well, you always have to apply feature scaling. And on the other way around, well, the models for which you don't have to apply feature scaling are the gradient boosting ones. So all the models based on trees that make predictions as a team. For those models, you don't have to. You must not apply feature scaling. So these include, of course, decision tree regression or classification. These include random forest regression or classification, and also XGBoost, LightGBM, and CatBoost. So yes, for those models, you don't have to apply feature scaling.